Good evening, Excellencies, faculties, researchers, scholars, academicians from various engineering and management institutes. Thank you so much for joining. I hope you all are safe and fine. It is an honor and privilege for me to welcome you on behalf of Satyug Darshan Institute of Engineering and Technology to this 5 days international symposium on data science, which has been organized by Department of Computer Science. I have the great pleasure of introducing Mr. Satyug Kumar as today's speaker. He is a gem with entrepreneurial capabilities and master of data analytics, artificial intelligence, machine learning, along with the blockchain and crypto technologies. He has 25 years of industrial experience, currently leading as Chief Data Officer at Farfetch, San Francisco, USA, delivering impact with the data and machine learning. Prior to joining Farfetch, he was Vice President for Data at Zalando, VP for Big Data Analytics for Ericsson. Also, lead the team for doing implementation on blockchain technology with artificial intelligence at Big Data Gurus, San Francisco, USA. He also founded Teletopia company in 2006, deployed more than 1.5 million TV sets worldwide. Teletopia was acquired by Concurrent in 2010. I welcome you, sir, for inauguration of symposium. Now, I would like to request Honorable Chairman Sir to grace and welcome our speaker of today symposium.
Good evening, everybody. Although maybe it is a morning for Satyug in US. So I welcome Satyug for this symposium, which you are the lead speaker for today's start of the symposium, which is going to last for another 4 days more. So definitely it gives me immense pleasure to be part of this I'll say that symposium, although I don't know much about the data, but only thing which I have heard of it or learnt of it is that data is future oil. And I'll not say it's a future oil. Maybe as of today also the data is a requirement of the day and it's becoming important for each activity of the business. So definitely this symposium is going to give us a good opportunity of learning from experts like Satyug and other people who will get associated with it in the days to come. And it is going to give a learning experience to all the faculty members of Satyug Darshan Institute, in addition to the students and other people who are joining this symposium from different fields of operation, maybe from academics or maybe from research and industry. So this is going to be a good symposium and I officially inaugurate it and declare it open. At the same time, I wish this symposium to be a great success and leading to the leading inputs of the speakers will definitely give insight and good learning opportunity to all of you. Thank you very much. And now I hand it over to Tanu Madam.
Thank you so much, sir. Now, I request our respected principal, Dr. M.N. Deshmukh, sir, to address the guests and participants.
Thank you, madam. At the outset, I would like to congratulate your Department of Computer Science at SDIET for organizing this international symposium. And I also welcome all those who are attending, either from the industry or the academia. We at Satyug Darshan are always looking forward to interact and make an industry institute interaction, strong interaction between the industry and the institute. And hence in this symposium, you will be seeing the right mix of the academicians as well as the industry people, because a lot of complaints are there by the industry that the academia are not giving them the right engineers coming out. So we have started involving the industry people, and Kshitij is one of them. I am nostalgic because he was my, since my college days, he was my classmate. He was a topper of his, of course, in computer science. I was from the mechanical side. And I remember that he was one of those who was brilliant in his area, and now he has carried his brilliance to the industry, and we are fortunate to have you, Kshitij, and I am sure all of us will be benefiting from your presentation. I welcome you. I welcome all those who are attending, and I won't take much time. I hand it over to Kshitij. Thank you. Thank you so much.
Hello, everybody. Can you hear me?
Yes, yes.
All right, perfect. Thank you, Dr. Deshmukh, and the faculty for inviting me here. It's very, very early here in California. It's 5 a.m. in the morning, 5:45 a.m. in the morning. So if my voice starts breaking, you'll know why. I've put together a presentation that's quite a bit longer than I usually do, because I wanted to give you a deep dive into what a practitioner sees with data science. So let's get started. Next slide, please. So a little bit of background about myself first. Of course, I'm the Chief Data Officer at Farfetch. Farfetch is a public company on the New York Stock Exchange with the ticker FTCH. I've been here just over a year, and I'm on the executive board of the company. What that means really is that when we want to get something done in the data space, we are able to do it. Because I'm in the executive board, and therefore we have the sponsorship of the board. My background, as we said, I went to school with Dr. Deshmukh at Manat in Bhopal. I went to Victoria, Canada for my master's. I've worked in a whole bunch of places. I've raised quite a bit of money with startups, sold some, acquired some. But the interesting part really is, while I've lived in Silicon Valley for the last 20 years or more, I was in Berlin, Germany till March when COVID happened. I was in the process of moving to London. And instead, I ended up flying back to California and sheltering here in place. And the way I got into big data was in 2012, I left everything I had and I said, I have to learn big data from scratch. So everything you're hearing about here, I never went to school with big data, with data science and machine learning. I was completely self-taught. So this is the practitioner's view. Next slide, please. Next slide again. So we'll start with the basics. I'm sure some of you have a lot of information about this. When we talk about data science, it's not just data science. There are really three parts to it. One is the data infrastructure itself, the ETLs, the preparation that you have to do with the data before anybody can even start exploring the data, analyzing the data, reporting it, visualizing it. And then you get to the data science, the machine learning, the artificial intelligence behind it. So when we talk about data, talking about just data science is not sufficient. There are three separate steps to it. Next slide, please. Now, diving a little deeper into each one of those steps. By the way, if you see names of products and names of companies, these are just for examples. This does not mean that we are using it today or that I recommend any one of them. In the infrastructure side, before you can actually start accessing the data, you have to first set up how that data is ingested, where the data is generated from. How are you going to access it? Whether you're going to access it through a data warehouse or a data lake. How do you actually prepare that data? So the extract, transform, and load process, which is a very common step, is part of this infrastructure part. But once the data has been extracted, once it has been stored, then how do you create the pipelines so that data science and analytics people can actually pull this data from there? Now, if you are familiar with Apache Spark, it's an open source set of tools. Databricks is the company behind Spark. Spark is literally the most common way of building your infrastructure, ETLs, etc. today. And MLFlow is one of the open source tools that work very closely with Spark. And I'll talk a little bit more about that as we go along. Next slide, please. Once you've got the data into your data lake or data warehouse, then the next step really is, how do you present and analyze this data? How do you first sit down with the business? How do you understand what the business problem is? Find which data is usable and then manipulate this data. And then, of course, it won't be useful unless people can actually understand the data. So presenting that data visually. And in order to do this, again, you have some tools like Looker and Tableau. Looker got acquired by Google last year, and Kibana, of course, is another open source tool. All three of these are tools that we use in our current organization today, and I'll talk a little bit more about them. There is nothing special to choose between one or the other. Every tool has some advantages and some disadvantages. What's important behind the scenes is the human being, and how do you get that analysis, and how do you actually visualize it in a way that people will understand. Next slide, please. And that leads us to the data science, the machine learning, the artificial intelligence. One thing to note about models is we often focus a lot on the models themselves, and the models are the core. The algorithms are the core. However, now we're getting to that point where you can actually buy models. There are pre-built models that you can get off the shelf. There are open source models as well that you can pick up. So it's no longer just important to focus on the models themselves, but instead also on the governance side. How do you own these models? Who owns them? How do you discover that data? Oftentimes you will find that organizations have so much data that it's very difficult for anybody to know what the data is, where is it? And then that entire cycle of data science, which is that explore, train, test, and deploy cycle. How do you make this happen? Some of the tools that you'll use in this, apart from the ones that I've already mentioned, could be things like Jupyter Notebooks to do exploration, or Colibra, for instance, to do data governance. It's critical, of course, to make sure that all of these tools work together with each other. The good news is there is so much focus right now on this, that this is the space that's changing really fast, and every big company in the world is literally looking at this space. So a good spot to be looking at. Next slide, please. Next slide, yeah. And so if I look at all of these things that we talked about and build it up from the bottom up, the data starts, if you're going to build machine learning at scale, the data starts with the sources. We start from the bottom. And then you could have things coming from the clickstream. So as an example, if you have a website, when somebody moves their mouse and touches and puts something into a shopping cart, etc., all of that information that's generated from there, it could be change logs, it could be transactional, goes into the infrastructure. In our case, we use BigQuery. We are on Google as well as Azure, so we use Microsoft. We don't use a lot of AWS, although I've used a lot of it in the past. Typically, the infrastructure now is a cloud-based infrastructure. And then, of course, once you've stored it, whether you've stored it in a data lake or a data warehouse, then what happens to that data? In our case, when you're in an online retail store, you have data about the sessions. When somebody comes to the website, what has their journey been? What have they done with the product on the website? What are the attributes of the product? And then, of course, once all of these data sets have been organized, you have tools like the ones I mentioned before, the Looker, the Tableau, the Google Analytics, Kibana, etc., that you can use in order to do this basic visualization. And then, of course, how do you pull all of these, including the machine learning algorithms, into creating things that, for instance, can create a bidding algorithm or can do the analysis. And then this, at the end of it, the very pinnacle of it, is where the value is generated. And this is where everything starts and ends. Even though we focus a lot on data science and machine learning, at the end of the day, what's important is how much value do you generate with data science. Next slide, please. So I'm sure most of you are familiar with the basic data science lifecycle. There are no surprises here. Even in the industry, we have exactly the same life cycle, pretty much, whether you're doing deep learning, machine learning, anything in the same area. It starts at the top with the exploration part of it. So you explore the data, you understand where that data is, you figure out how to fetch that data, how do you pull it in, how do you prepare it before you're actually going to work with it, and then start training the model. Now, one thing to remember is this extraction, fetching, and preparation of data. This is probably 70 to 80% of the work that data scientists end up doing in the beginning, until they've got the processes right, until they've got the tools right. A lot of the work that happens in the beginning is in this space. It's not very exciting work to begin with, but then when you actually get to the next level where you start training the models and then doing evaluation, A/B testing, experimentation, etc., and then really actually deploying it to production and seeing the impact of the data science models, the machine learning models, the AI, that's when it gets really exciting. And then, of course, you have to continuously monitor and evaluate, because your data will change, your data sources will change, your models will have to adapt, and then the whole cycle starts again. Next slide, please. So if I summarize this entire tech stack that I've been talking about, on the left-hand side, it's a simplified version of the diagram you saw, which is the explore, train, test, and deploy cycle. The tools can change. So in the exploration, I mentioned Jupyter Notebooks. You can use Pandas, Scikit-learn, etc. Many different tools out there, and they are available to everybody, whether you're sitting in India or you're sitting in the US. You are actually getting access to exactly the same set of tools. The training as well, it might get a little more expensive if you use things like GPUs, but I would highly recommend working in the cloud. Much easier, much faster. I would recommend using all of the tools, such as the cloud tools, Keras, PyTorch, etc., TensorFlow, and then of course A/B testing, Bayesian methods. All of these very popular, very common. You can get them everywhere. And then deployment typically nowadays is in the cloud. So I would highly recommend, especially in a time like now with COVID, what we are finding is that we have a lot more flexibility because we are already in the cloud 100%. And especially that part, the data infrastructure part at the very bottom of the tech stack, becomes a lot easier when you've got on-demand storage and on-demand compute. All right, let's go to the next slide, please. So changing topics a little bit, something that we don't talk about enough, neither in industry nor in academia, I think, is the governance part of it. So what you will realize once you deploy these things in a real life is that governance is how you make sure that everything stays safe, how you make sure that you know what the ownership is, you know what the lineage is, understanding, having that visibility on who owns the data, where is that data coming from, who modifies that data, as well as retraining it, as well as understanding what happened in runtime, and then actually storing things in version control, knowing what data is used by whom, when, All of these are important, critical things. Let's go on to the next slide, please. Again, 4 important things here, which are the machine learning reproducibility. So develop the model, maintain the model, create some methodical processes, and then create variation in the data sets. When you create these data sets, you have to be able to test them out afterwards to make sure that they're actually working the way that you want them to be working. Going on to the next slide quickly. Really 2 things you have to worry about. If you're a software person, you'll understand that code that you have used to train the model and the environment in which it was trained is important. You want to be able to go back to how you trained it, where you trained it from. But then the other important part is the data. If your data has changed, then your model will work differently. So the code that you've used to train the model, the environment in which it was trained, and then the data that you use to train the model. These are components that must be versioned and maintained so that you know when you come back 6 months down the road, what worked and what didn't work. You're able to compare it against the information on the code and the data side, and therefore you'll be able to reproduce it. Let's go on to the next slide, please. Now, I'll give you an example here of something that we use in industry today. This is called MLFlow. MLFlow comes from Databricks. Remember, I was mentioning to you Spark earlier. MLFlow is open source. Anybody can download it anywhere in the world. I'm not recommending MLFlow. I'm just saying that this is one very good way of using open source in order to standardize the machine learning workflow. You can create and package and serve models with it. It also has a user interface so that it's no longer, you don't have to do everything by hand. There is a good API, there is a user interface, you can log the metadata, you can tune the hyperparameters, you can tune the performance of the model. And these provide some of the basic requirements for machine learning that you'll be able to use. By the way, very similar products come from Amazon, like SageMaker and others. Happy to sit down and have a longer conversation about these, but this is an example of the kinds of tools that are available today. If you step back 4 or 5 years ago when I started doing machine learning and data science, you had to do everything by hand. You had to go into R and do things by hand and store things with spreadsheets. Today, we are lucky that we already have a lot of these sophisticated tools that exist. Next slide, please. And we talked about, if you remember, we talked about code versioning and data versioning. Code versioning, if you're a software person, you know there are many tools out there for using code versioning, like Git, for instance. But they are not really suited for data versioning. And so there are a couple of open source tools that you can use. Data version control is one, which is built for data, as the name says. It is built for machine learning. And it works very well for versioning data sets. We do use it oftentimes. And then there are some more proprietary but still open source tools like Delta Lake. Delta Lake really is something offered by Databricks, built on top of an open source data lake. So it allows things like snapshotting. You can go back into time and say, what was the data I was using 2 days ago? What was the data I was using a week ago, a month ago? So that you can reproduce what worked and what did not work. In practice, what will happen is that your models will become better with time, and then sometimes suddenly they'll become worse with time. And that's when you say, something went wrong. I need to go back and correct what went wrong, and I need to check against what happened before. That's where these version control tools become very important. Next slide, please. So just summarizing, all of the things that you've seen so far is the deep dive into technology. This technology exists today. You can go out, get it, download it. Everything I've talked about is open source. You can use it. There is enough information on the web on how to use it. What's not visible is most people do not have a very simple, very thorough understanding of how the industry actually uses data science. So I thought I would give you a deep dive into how industry works with data science. This is an example from my current company. The company is called Farfetch. Farfetch is the world's biggest platform for global luxury fashion. And what we do is we are a platform, so we work with boutiques and brands around the world, Dolce & Gabbana, you name it, Louis Vuitton, the biggest brands in the world. And we help people buy fashion, luxury fashion. Everything is online for the most part. Next slide, please. We are, like I said, the #1 full price destination in the world. We get over 35 million unique monthly visits. We have more product than anybody else out there. By the way, we sell to 190 countries in 16 local languages. Mostly digital. We do have some stores on the ground. One interesting thing that happened is that with COVID, we realized that this distributed model that we had built, completely cloud-based, completely data-focused, is a very good model to have at this point of time, because when things go bad in China, then things are decent in Europe. When things go bad in the US, things go better in China. So having a distributed, data-driven, cloud-based system across 190 countries has been a really strong thing for us. There's a lot of public information about this. We are actually still doing quite well on our promises to the stock market. I won't speak to them, but you can find all that information online. Let's go on to the next slide, please. Something I wanted to mention here is this is not just one company. This is multiple companies. We have a marketplace that actually helps across all of these. One interesting thing is we are doing a lot of work in India. I was in India, I think 7 times in the last year, and this was only until January, February. If you are interested in working with us, we have an office in Gurgaon, and we are always interviewing people in the data science space and the machine learning space. If you're interested, reach out to us, check out our website, and you'll find a lot more information there. Let's go on to the next slide, please. So just one final slide on what we do. There is, if you ask anybody in the younger demographics, they will recognize these names as some of the most popular luxury brands. So Off-White, I'll take the example of Off-White. Off-White is like a cult classic right now. Palm Angels, another really important brand out there. These are the brands that we sell, and this is part of our company as well. The name of the website is farfetch.com, farfetch.com, and you will find all of these things on the website. Next slide, please. All right, just one interesting point. So remember, we were talking about data science. Our data science problem is very sophisticated. And the reason it's very sophisticated is we sell from over 2,000 points across the globe. So think about it. If you're in India, if you're in New Delhi, and you're buying a purse, Dr. Deshmukh decides to buy a purse for his wife. When he purchases that purse, it is going to be shipped from anywhere in the world. It could be from any of these 2,000 points, wherever it's available, whatever is the fastest, cheapest, and the best way to get it to him. There are over 3,000 brands that we work with. There's over 1.8 million customers we work with. These are 2019 numbers. I don't even have the 2020 numbers in front of me. What this means is, in data science, remember, every one of these is a data source. Every brand, every stock point, every customer who comes in is a data source. In order to do data science, you want to collect all of this data, clean it, make it available, and then use those tools that we were talking about in order to be able to do the machine learning and to be able to create the value out of this. Next slide, please. And so how do we then actually use this data science in retail? Let's see the next slide. This is a screenshot. Oh, actually, before we get to the screenshot, when we say data, by the way, we don't just mean data science. We mean everything from the data itself, the producers of that data, all of this data that I was talking about that's collected, the infrastructure, the engineering, the predictive analytics, the quality, the governance, those tools that I was talking about, the machine learning, the AI. So we don't talk about data science by itself. We talk about data science as part of the entire data cycle. Let's look at the next slide, please, and I'll show you some examples of how this actually works. But what are we actually doing? We are making sure that the customer gets the right product using data science with the experience we want them to have. Remember, this is luxury. People are paying a lot of money in order to buy these things. They have to have a really good customer experience, and it needs to be offered at the right price. It cannot be too expensive. It cannot be too cheap. It has to be the right price. And then once somebody is actually purchasing this, it needs to get to the right place at the right time, whatever we have promised. Every one of these steps that I'm talking about are driven by data science and machine learning. Next slide, please. So, next slide. At the center of everything we do is the customer. So whether you're doing marketing, whether you're trying to, when somebody goes to Google and does a Google search for Dolce Gabbana or Off-White or any of these brands, this is driven by data science, whether it's Google driving it, Bing driving it, or we building our own algorithms to drive it. We want to make sure that the person who is the right person for our website gets exposure to it and is able to come to the website. Now, we also measure on-site behavior. Once somebody is on the website, what are they actually doing? Once they bought it, did they actually return it? Why did they return it? What kind of customer service information happened? What happened in India versus in Dubai versus in New York? And then loyalty, did they stay with us? Did they come back and buy again? Or did they just buy it once because it was at a very good price? What kind of preferences do they have? What kind of brands do they like? What kind of styles do they like? Knowing and understanding your customer is the bottom line. It's critical, and that's where we start from. Next slide, please. So this is actually a screenshot. I took a screenshot from our website. If you remember, I was wearing a black coat in the first picture that I showed you, and I thought I would show you how I actually ended up buying it. So you go to the website. This is Farfetch's website. You look for the black coat that you're looking for, and it starts by giving you some of the possible options that you have. Of course, when you look at it, you realize that some of these are actually personalized for you. This is based on my previous browsing history in real time, understanding which are the ones that I would prefer to possibly buy and have the right experience. Next slide, please. Once we have selected one of these, it'll actually start showing you others. If you like this first one, what are the other things, maybe other styles? As you see, these are now suggesting different styles. Again, this is all recommendations. What's actually happening behind the scenes is that you've got something like Elasticsearch running in real time. You've got models built behind the scenes that are actually showing you the ones that are most likely going to be interesting to me as a person. Next slide, please. And then when you have actually selected one of those, then what happens is you have to predict which size is going to work for me. I'm not a very tall man when I'm living here in Europe or in the US. Most of the jackets and the coats that are sold in sizes that are way too big for me. So if I was to purchase a really expensive jacket and then have to send it back because it doesn't fit me, that would be a problem. So this fit prediction, how do we recommend, how do we understand what is the right size for KK in order to make sure that KK has the best experience? That's all done with machine learning behind the scenes. So you may not see data science here, but when you see that fit predictor calculating your size, that's actually coming from a machine learning system behind the scenes in real time. If you see that estimated delivery date, where it says if I bought it today, it would be delivered between July 16th and July 20th, that's based on already understanding where am I doing this surfing from? Where am I going to buy this? And what kind of place will I be able to send this from? So it's not just where I am, but where are those, you remember the 2,000 points that we could be selling it from? Where are they located? All of this is driven by machine learning. Let's go to the next slide, please. And then, of course, while I'm buying this one thing, what about all the other information? So if I'm buying a jacket, maybe I may be interested in jeans. Maybe I'm interested in an undershirt. What about the shoes that the model is wearing? What are the ones that are going to be suitable for the person who is browsing? And of course, remember, this has to be all done while keeping privacy in mind. So you don't want to have too much information about the person who's browsing. And if you do have information about that person, you want to make sure that it is limited to them and not shared with anybody else. This is part of that governance that I was talking about before. Very important not just to have good models, but to have governance around it to make sure that the customer is safe and their data is safe. Let's go on to the next slide, please. So that was the experience on the marketplace. But remember, data science and machine learning actually happens before you even get to the website. So if you look on the left-hand side, the production, when some product is going to be sold, before it's even put live on the marketplace, how do you actually take the pictures? How do you actually extract the features? How do you put that product on the marketplace? Then going on to the right-hand side, when somebody comes and searches for that product, how do we find that product? How do we make sure that they are able to use the right kind of credit cards to purchase it? How do we make sure that the seller, because remember, we have somebody who is shipping this, which may or may not be our company. And how does that seller actually know where this is going to go, what kind of information they need to know? Then the carrier, remember the DHL, the FedEx, the UPS, the people who have to actually deliver this product to the end, they need to understand, where am I going to pick it up from? When am I going to be able to deliver it? And the customer, of course, in that whole cycle has to understand, when am I going to get it? Is it actually on track? Is it going to be delayed, etc.? And then on the bottom left-hand side, see the customer service side. Again, completely data-driven. Now, this has all of the ones that I talked about before. There is data engineering, there is analytics, there is data science, machine learning, and artificial intelligence applied to every part of this picture. Let's go on to the next slide, please. So I'll take a very specific example in this case study. Next slide, please. This is the estimated delivery that we were talking about. So when somebody has ordered, once they've looked for the product and they've placed that order, let's take the example of how do you actually tell them when is it going to be available to them. Now, we used to show them an expected delivery time that it's going to be 3 to 5 days, and you can choose a regular delivery or express delivery. Next slide, please. It would also show them where they're coming from. But now when we took this and we said, we're going to narrow it down very much and tell them you're going to get it on Wednesday morning between 10 a.m. and 12 p.m., we noticed the business benefit of it, which is customers are 13% more retained. That means, you know, if a company is making $1 billion a year, imagine that's $130 million more that you can generate from those same customers. If when you say it's going to be there is when it actually gets there. The number of converted customers go up. Remember, data science, machine learning, everything starts from the customer. If the business does not get the benefit from the data science and machine learning, then in industry, we're doing something wrong. Yes, we also do research, but most of the work that we do is how do we make that experience better for that customer? And this is how you find out that the experience is better for the customer. Let's go on to the next slide, please. So how do you actually do this though? When you're looking at the data, remember the data is coming from the customer. It's also coming from the store that's going to ship. It's coming from the FedEx or UPS or DHL that is going to ship it. And then there is time. There are things that are happening along a period of time. So you have to collect the data from every one of these places. You have to train it, you have to prepare it, you have to deploy it, and then run it in real time in order to be able to get all of the variables that are going to influence this delivery date. Next slide, please. And so we built this, we trained the models, we went live with it. This is a screenshot from an earlier version of it. As you can see, if you do the standard delivery, we are not that accurate. We would still say, hey, it's going to be delivered between this date and that date. But if you did express delivery, you can get pretty confident that it's going to be a specific date between October 3rd and October 4th. In some cases, if you are delivering within the same country, then you can actually say it's going to be between 10 a.m. and 12 noon. Of course, if I'm shipping from Italy to India, then you have to worry about customs, etc. This is the reason why you can't often be very, very accurate. Is it going to be October 3rd or October 4th? We don't know yet because it does depend on whether customs takes longer or not. So even though you may have done everything right with machine learning, with data science, you are still dependent on the real world and what happens there. This service is now live on our checkout page. If you want to check it out, it actually works today. Next slide, please. So what happens after the model has gone live is you don't stop at that time. You keep monitoring it. Is it actually working the way that you expected it to work? We update the model. We are creating, a periodic model training. We're trying new architectures to see how we can get even more accurate. We are watching how customers are behaving with it. Are they happy with it? Are they not happy with it? And then we're expanding the scope sometimes. What more can we do beyond what we've already done? So this is not a static thing. Machine learning and data science is always dynamic. You're always going to continue to change as the data changes, as the customer behavior changes. Next slide, please. So finally, next slide, please. I wanted to tell you that as you do all of these things, there are two separate sides to it. One is the machine learning and the data science itself. The important part is you have to work very closely with those who have the domain knowledge, those who, in our case, those who really understand fashion and those who really understand how those customers work. Data science becomes successful when we combine data science knowledge with the domain knowledge. That's how we become a win. So if you think about that journey that we talked about, which is getting those customers in the first place, attracting those customers, giving them that experience, the search experience, the rank experience, the product recommendations, giving them the delivery that we just saw the use case on, predicting when it's going to be there, predicting when somebody is going to return it. We can actually tell sometimes that somebody who is buying something is going to return it. And if that is the case, then why send it to them? Instead, why not reach them by customer service and talk to them and make sure that it's actually the thing that they want to buy? Otherwise, you're shipping it over multiple countries and you may have to return it. As well as promotions, geo interest, et cetera, and then forecasting all of this. Remember, in a place like, in a state like COVID right now, very difficult to actually say, where is that stock? How do we optimize the stock? Who is going to buy it and when? Where are we going to get it to them? And every step of this journey is driven by machine learning and data science behind the scenes. If you can go through the next few clicks, please. We have been writing multiple papers. If you do a web search, you'll find some of these papers. And next slide, please. So you'll see a whole few, there are a few different things that we talk about in natural language processing, different models we're building for image classification, etc. And so this is how you actually connect what you're learning at school, working on in the university, in the academia, with what happens in the industry. We take those same things that you're doing and then we convert them into something that the industry actually uses and generates revenue and customer interest from. How does academia work with industry in Europe and in, I was speaking at the Imperial College in London 6 months ago, and I mentioned to them, next slide please, that for industry and academia to work together, remember these are two sides of the same problem in machine learning. Industry has real practical problems that we must solve in personalization, in supply chain, in sustainability. And academia has these theoretical as well as applied research that you can perform, you know, the algorithms, the experimentation, the behavior analysis. We oftentimes in the industry don't have the resources and time to be able to spend on that research, even though we might want to do it. And so how do you combine what the industry can do and how do you combine what the academia can do in order to give consumers what they need while doing what needs to happen for the world? Together, I believe industry and academia in data science can work together to solve a lot of these problems. Next slide, please. And finally, Farfetch, we are doing a lot of work in this space. If you're interested, as I mentioned, we have an office in Gurgaon. We have exciting problems, lots of data, and we have great data scientists. We are looking for more data scientists as well. Find us, reach out to us, and look forward to hearing from you. Next slide, please. And I think that's the last slide from me. Thank you very much. I'm happy to take some questions if there are any. Go ahead, Swati, you were saying something. I saw a few questions on the chat coming by where somebody was asking, for instance, do we keep records of people's information? So there are, every website that actually runs these algorithms, if you think about it, if you're on Flipkart, for instance, or something similar in India, they are actually doing almost exactly the same thing that you saw here, just at a different scale with different products. And so information is always there with these websites. The question is, what do we do with that information? Do we store it? In Europe, there is GDPR, which is a set of laws that protect the customer. In the US, similar laws are there. India is deploying similar privacy laws. So as a data scientist, you have to be very careful. You have to know what data you can use and what you can't use. And when you share the data, you have to be sure that it's not getting shared outside of those people who are supposed to have access to it. All right, I'm open for questions, more questions if anybody wants. I'm seeing a question on the chat which says data science and artificial intelligence can be helpful in digital marketing also. If yes, how? So absolutely, digital marketing, especially performance marketing, is totally built with data science and machine learning. So when you do, if you take, this is something you should test out. Go online and search on Google for anything that you could be wanting to buy. If you search for anything that you want to buy, what you will find is that there will be a set of paid results at the top. Now, those paid results are coming from hundreds or thousands of companies that might actually be wanting to have you as a customer. What happens is every company that is actually doing that decides how much money they are willing to spend to get you as a customer. So this is actually driven by machine learning behind the scenes. It could be Google's machine learning algorithms that are doing it, or it could be the company's machine learning algorithms. So yes, the answer is yes. Marketing is driven heavily by machine learning. Even loyalty programs, for instance, who do you send an email to? Let's say that Dr. Deshmukh bought that purse for his wife. When should we reach out to Dr. Deshmukh again to see if he's happy with it? Whether we should send him a coupon code for the next one so that he buys it for somebody else. What would he be interested in? These are the kinds of things that have to be driven by machine learning behind the scenes. All right, let's see other questions. There is a question from Neeraj asking why every other person, be it science or commerce background, wants to come in AI and ML, now data science. What's a good solid reason for that? It's a good question, Neeraj. The reason that people want to work in data right now is these are phases, of course. If you think back 10, 15 years ago, everybody wanted to work in software. Everybody wanted to be a software engineer. And why was that? Because we were in that phase where software was just becoming useful, becoming popular. The cloud was just beginning to happen. And so there was need for a lot of software people. Today, it is the stage where data is available, data is plentiful, and there is need to solve those problems in data. And so this is not a fad. This is real. I can see it on the ground right now. Some of the people here, I'm in California now. As you can see, it's beginning to be morning right behind me here. The sun is rising. And I find here in California, machine learning people, data science people are the hardest to find. So in fact, people like us, companies like us are going to places like India directly instead of hiring them here. Why not work with people like yourselves in India? So I would say the solid reason for data, AI, and ML is the data is plentiful now, the tools are there, the processes are there, and we are actually able to, because of the cloud, serve the results in near real time so that it is actually artificial intelligence can be done effectively. And that's the reason why I think many more people are going into machine learning, etc. All right, so question from somebody, let's see, Sahil is asking, COVID scenario must have changed the behavior of customers. Yeah, go ahead.
Sir. Good evening.
Yep.
Sir, I'm Ravina Sultana from Army Public School, Jhansi. Sir, my question, as you explained, that all the data is on cloud computing and how it works, how the appropriate product is reached to the customer, and how the services they give to us, and how they take care of our doubts and many things you have explained. But as the academically as a teacher, how it will be useful for the student and the teachers for the teaching and the learning purpose.
Very good question, Rina. Thank you for asking. So what we are seeing on the, it depends on which level you are teaching at. I think you mentioned you're at the Army Public School, which means you're teaching until grade 12. If you think about, if you've used Siri, for instance, behind Siri on an
yes,
Apple
sir.
phone.
I'm PGT Computer Science and I'm taking class 12 CS.
Class 12 CS, yes, thank you. So if you think about Siri, for instance, behind Siri, everything that happens behind Siri is actually driven by AI, by ML. So for when a student actually asks a question, I find people are asking questions that they need answers to. Instead of doing a Google search, they're actually using voice to get questions and answer those questions. Everything that's happening behind that is actually machine learning, is artificial intelligence. For a student who is in 12th grade to actually use the data today, Unfortunately, we are not there yet that they will be able to do a lot of those things today. However, what I would suggest is I have seen students in 11th and 12th grade going to Kaggle. If you look at kaggle.com, Kaggle is a data science competition. What I would suggest is anybody who has an interest in machine learning and data science, go check out what's happening on Kaggle. And don't get scared, don't get worried, because people who are working there are PhDs as well as bachelors as well as 12th grade people. I would say take advantage of those open source tools. Kaggle provides data sets. The hardest thing for a school student or a university student even to learn data science is, where do you get the trusted data sets from? And places like Kaggle, for instance, will give you those data sets. There is lots of information out there about how to do machine learning with completely open source tools, so that you don't have to spend any money beyond actually having an internet connection and a computer that you can connect to. So I would say lots that can be done. Of course, it becomes easier and more effective as you go further into the bachelor's, master's, and PhD. More questions? Otherwise, I can pick up some questions that are on the chat. Somebody asked, how big is big data? That's a moving target. Big data changes. I think 10 years ago, if I looked at big data, a few terabytes was big data. Today, petabytes are easily handled across the world. So it's a moving target. Big data is just very large data that is difficult to handle on a single computer or a few computers. Let's see, what's the next question? There was a question I was beginning to answer about COVID, which is, somebody said that there is customer data that is stored from before, and the behavior is completely changed now because of COVID. That's a very good question, because what's actually happening is that customer behavior depends completely on whether you are outside the house or inside the house. COVID has completely thrown everything on its head. This is going to happen again in the future. So it's a great point. We have to adapt. We have to learn from what we have seen in the past, and that's how machine learning and artificial intelligence works. However, nature throws us a curveball sometimes, and so you have to actually relearn yourself, and for some time your machine learning models are going to be off. So I would suggest that yes, you have to relearn, you have to retrain, and that's how you continue to give useful information. By the way, the old information hasn't gone away. It hasn't gone bad. Customers still think the same way that they think and they used to think before. So I would suggest taking advantage of past information and then retraining with new information as it happens. And that's why the human element is so important as well. Okay, Dr. Deshmukh, do we...
So there was one question from Dipesh Tiwari. Hello, sir. Does big data can also be used as training data? What will be its effect on trainee model? What training data is used in the case study of delivery time prediction you discussed?
So it is a big data problem. The delivery time prediction is definitely a big data problem. And if you think about it, with 1.8 million customers around the world and doing this for 12 years, we have a lot of information about when things actually get delivered versus what did we actually predict for it. So the important thing really is, as an engineer or as a data scientist, you have to take decisions on whether you store all of that data or not, and how much of that data you store, when you store it. If we had let that data go, for instance, in the delivery date example from the past, we would not be able to adapt to it. So it's really important to use that data. It is big data for sure, millions of customers, millions of orders over a period of time. The good news with something like an estimated delivery date is that it only happens so many times, which means that you have time to actually train and retrain. If UPS or DHL or FedEx starts doing things slightly differently, we have the ability to relearn. So training is critical on that big data, but it can change. So with COVID, for instance, delivery dates have become longer. It's much harder to actually predict if you're going to be able to do things at the same time as you had learned beforehand. So valid question. It is big data. You actually do pick up this information and you do train your models with that. I think we're getting to the end of our time. Maybe we'll take one last question. Dr. Deshmukh, do you have any questions?
No, fantastic. It was a typical industry flavor we got.
Exactly. Yeah.
It's altogether a different viewpoint because the industry has its own flavor.
Exactly. Yeah. That's what I wanted to do, Dr. Deshmukh, is give your faculty and your students a chance to understand that research is important for us, absolutely.
Yeah.
But it has to be practical research. It has to be applied research. How can we take advantage of it? Yeah. Especially in today's time, right? With COVID, what has happened is so many industries are going down. It has become really hard, whether you're a small business or a major enterprise or a Google or Amazon. Everyone is suffering. And so how can we take advantage of data science and machine learning in industry in order to survive this COVID phase and go back to being able to do a lot more research for research's sake?
New normals are being defined.
Exactly.
Although abnormals.
Yep. And they will become new normals. As you said, like somebody asked the question about retraining the customer behavior. You said it exactly right. It is a new normal. So our models, you can't hard code these models. That's why this is deep learning. That's why it's machine learning. You can retrain those models and find out those new ways of working and then use them to deploy.
Right. Case studies are to be introduced. What I have gained from this lecture is, I am from the mechanical side, but we need to incorporate case studies. That is what will make us closer to the industry, come closer to the industry.
Exactly. I think, and also for your students as they graduate from college, to have some of that knowledge about those case studies and be able to even possibly work on some of them. When you go out and look for a job, you will actually have a much easier time because you would have seen some of those case studies working closely.
Right. Gives you the taste beforehand.
Yeah, exactly.
I think we have taken a lot of your time. It's, I think, more than 1 hour. I'd request our head of the department to give the formal vote of thanks. Kaushal.
Thank you, sir. Honorable Speaker, sir, Mr. Kshitish Kumar, respected Principal, sir, Dr. Aman Deshmukh, and all the participants here. It's my privilege to have been asked to propose a vote of thanks on this occasion. I, on behalf of Department of Computer Science, extend a very hearty vote of thanks to the Honorable Speaker, Mr. Kshitish Kumar, who has honored us with their presence and took out a valuable time of his busy schedule. I must mention our deep sense of appreciation for Mr. Kshitish Kumar for his work, and the way he explained the topics is really exemplary. Also, I would like to extend a special thanks to Principal Sir Dr. Aman Deshmukh for inspiring us and providing us the platform to organize this event. I heartily congratulate to all the participants for their active participation in the event and the organizing team of the SDIET and the entire Computer Science Department of Satyug. Thank you very much. Thank you.
Thank you, Kshitij. Thank you for your time and efforts. And of course, very odd time you had to get up. We were working with UK time and it's US.
Yep.
Must have been tough.
Yep. No, thank you, Dr. Kaushal, and thank you, Dr. Deshmukh, especially for reaching out to me after almost 30 years of not having talked to you. It's a pleasure to actually be here, and I'm happy to give back to the Indian community, even though I'm in San Francisco right now. So thank you for having me.
We'll look forward for more interactions, and hopefully things go normal. Then we'll call you, invite you physically when you are in India. Do tell us whenever you next visit.
Definitely looking forward to it. Thank you, everybody, for taking the time. Thank you, Dr. Deshmukh.
Okay, thanks a lot. Thanks. Okay.
Bye-bye.
Okay, bye-bye.
Okay, thank you, sir.
Thank you, guys.